says here, classify these compounds as strong electrolytes, weak electrolytes, or non-electrolytes. So I have FeCl2, and then I have H2SO4, and then I have HCN. So it's saying strong electrolytes, weak electrolytes, or is it a non-electrolyte here? So basically, when we're talking about electrolytes here, we want to dissolve them in terms of water, right? Because basically what we want is we want to find the ions here, and these ions are going to play a part in terms of our carrying electrons and carrying electric current here. So if we were to dissociate all of these compounds here, we have iron 2 chloride. We're going to dissociate this into Fe2 plus and Cl minus, right? We can also balance this as H2Cl minus. That's totally fine as well. We have H2SO4. This dissociates into, again, we have H plus, and we have HSO4 minus here. And then finally, we have HCN here, and this associates to H plus CN minus, and this is hydrogen cyanide here. So we have all of these compounds here. So FeCl2 plus, and we care about the dissociation, right? If this dissociates fully, it will become a strong electrolyte. So if dissociates completely, then strong electrolyte. So in this case, FeCl2 dissociates fully again to its cations Fe2 plus and 2Cl minus. Therefore, this is a strong electrolyte. H2SO4 is a strong acid, and it's going to therefore dissociate completely, right? So this will be also a strong electrolyte. However, if we had HSO4 dissociating, then that actually becomes a weak acid. So it depends on the because it's a polyprotic acid. H2SO4 is a strong acid. However, HSO4 minus is a weak acid. So we have to be careful of this here. Hydrogen cyanide, HCN here, is a weak acid. Therefore, it is a weak electrolyte here. So we can also search up. I can also search up for you HCN's pKa. Just to kind of verify this. So hydrogen cyanic acid is a 6.2 times 10 to the negative 10 here. So because it has a Ka of not 1, it's not going to dissociate fully into its ions here. So this here is actually instead of a dissociation here, this would be a equilibrium reaction. This cannot go forwards and backwards here. So now we know our answer. This is a strong, and weak. And they got this completely right as well. This is a strong electrolyte, weak electrolyte. And they justified it using a weak acid, strong acid, and it completely dissociates into ions here. So this solution here is correct. So correct solution, good analysis.